Imagine an asteroid the size of a stadium. That will hit Earth in 2 weeks. Even a medium-sized one like this, a small asteroid brighter than the Sun, would tear through the atmosphere at 60 times the speed of sound. Its destructive power would be equivalent to 4,000 Hiroshima bombs, flattening cities and killing millions. This is not science fiction. Many deadly asteroids are only discovered at the last moment. In 2019, an asteroid the height of a 30-story building, was discovered, just the day before it passed Earth. It was closer than some of our satellites. Last year, a larger asteroid, Mk, was discovered, only 13 days before it flew past Earth, closer than the Moon. If they had struck Earth, their destructive power would have equaled 3,000 to 9,000 Hiroshima bombs. Shockingly, humanity has no real plan for this. Scientists have devised various methods to push dangerous asteroids away, like painting the asteroid to deflect sunlight, installing thrusters to control it, using lasers to burn it, or even colliding a spacecraft with it. But all these methods have a major problem. They're like trying to move a cargo ship with a bag of potatoes. They can move the asteroid, but only by a tiny amount. Using these methods, you would need to act years, or even decades in advance, to make the asteroid miss Earth. Recently, scientists have developed a brand new, astonishing method to destroy deadly asteroids. And we could actually implement it with today's technology. Let's see how this method works. On a 100-meter-wide asteroid heading for Earth, the secret weakness of asteroids. For a long time, people thought asteroids were massive rocks, made of stone and metal. But in reality, most asteroids are more like loose rubble piles, heaps of pebbles, precious minerals, and dust barely held together. This means, instead of just nudging them, we can do something better, crush them. The obvious choice? Nuclear weapons. So let's go. We load a warhead, launch it, aim for our deadly asteroid. Oh, the asteroid destroys the nuke. Asteroids can approach Earth at speeds of 70,000 kilometers per hour, fast enough to cross the Atlantic in 5 minutes. Any bomb we create would not survive such an impact. If we collide head-on, the asteroid would destroy the nuke before it even explodes. Simple solution. Detonate the nuke before it touches the asteroid. Scientists calculated the optimal distance. For our 100-meter killer friend, it should be tens of meters from its surface. Launch, set the timer, boom. The explosion leaves a huge crater, and that's it. Unfortunately, there's no air in space to transmit shockwaves, so most of the explosive energy is wasted. 2 weeks later, the asteroid would still hit us, just a few kilometers off to the side. Hitting such a behemoth with a nuke is like hitting a cargo ship with a washing machine instead of a potato. Better but still useless. Alright, let's try a Hollywood approach. Send humans to the asteroid, drill a hole, plant a nuke inside. In theory, it works. In practice, suicide. Landing on any celestial body is a nightmare. Even on a reasonably large Mars, we barely understand its surface. About 70% of attempts fail. Imagine doing this on a small, fast asteroid discovered only 2 weeks prior. Sending astronauts and a nuke to land on it, what are the odds? Even if successful, drilling in microgravity is extremely slow, because there's no downward force. We would need far too much time, and we don't have it. Unfortunately, this isn't the answer. We must think less like Hollywood, more like lumberjacks. A smart approach. If you want to split a log, you don't hit it with a rock. You use an axe-dense, perfectly shaped, a tool made for splitting. Similarly, scientists have discovered a new tool to destroy asteroids. Ultra-dense, ultra-fast space bullets. We don't even need to fire them. These space bullets, called penetrators, are a few meters long, slender, made of tungsten, a metal denser and harder than rock. Their principle is simple. Place the penetrator in the asteroid's orbit, floating quietly in space. From the asteroid's point of view, it wouldn't see a few small bullets stationary. It would see them hurtling toward it at 70,000 kilometers per hour. Speed doesn't matter who is moving. But at this velocity, the most time-consuming part of the mission is simply getting to the asteroid in time. We cannot destroy it too close to Earth, because debris would hit the atmosphere simultaneously, with the force of thousands of nuclear bombs. Our atmosphere can absorb isolated fragments, But thousands at once would create cumulative shockwaves, killing millions. So we must intercept it a day before impact, when the asteroid is roughly 2 million km away. More than 4 times the distance to the moon. Far away, but doable. Our current rockets can reach it in about a week. We'll launch one penetrator, about 2 meters long, 2.5 tons. Once the rocket arrives, it places the penetrator, maximizing destruction. A tiny point of light appears far away. Then suddenly it speeds toward us at supersonic velocity. The asteroid strikes the penetrator so fast. The force released equals 120 tons of TNT. Rocks evaporate, tungsten melts, leaving a penetrating scar on the asteroid. The asteroid shatters into thousands of fragments, forming a cloud. The next day, debris hits Earth, scattering over hundreds of thousands of square kilometers, turning a potential apocalypse into an almost harmless cosmic fireworks display. If we prepare, discovering a deadly asteroid 2 weeks in advance is enough. But what if it's a mountain-sized planet killer? An object with the destructive power of tens of thousands of nukes. What then? Non-avian dinosaurs could tell you, but they're dead. Planet killers are enormous, capable of destroying most life on Earth in one strike. The most dangerous come from the outer solar system, comets. Distant, dark, and difficult to track. Comets are mountain-sized dirty ice balls. Weaker than pure rock but faster and more violent, about 140,000 kilometers per hour. In 2020, Neowise was discovered. Its power equals 6,000 times all nuclear weapons on Earth. And it was only discovered 4 months before closest approach. If we detected such a beast 6 months before impact, would we have a chance to survive? Unfortunately, it would be extremely difficult. Planet-killer comets are so massive that simply breaking them into millions of pieces isn't enough. The debris would still be large and numerous, enough to ignite the sky and kill most life on Earth. We would need to deflect most, if not all, of the fragments. Far from Earth, even near Mars. To destroy such a mountain, we'd need thousands of penetrators. That's a huge problem. To fly that far and deliver that many payloads, we'd need at least 24,000 super heavy rockets. To date, humanity has 2 and they aren't even finished. Even if all industries switch to rocket production, we couldn't do it in time. If we discover a planet killer today, we are helpless. Unless maybe we combine penetrators, a touch of Hollywood and nukes. To make it work, we'd need everything ready in advance. A rocket like NASA's SLS, carrying all components, ready to launch. Once the planet killer threatens humanity, we launch 5 months across empty space. Life on Earth continues tensely. At Mars orbit, we deploy 5 massive penetrators, in a perfect 2-kilometer-long line precisely timed. Only one chance. Brave astronauts monitor the process. They cannot return. The moment arrives. The comet strikes the first penetrator at 140,000 kilometers per hour, releasing 2,000 tons of TNT energy. Ice, rock, and tungsten instantly liquefy. Impact consumes tens of meters of the comet. Second, third, fourth penetrators repeat the process, forming a 100-meter deep tunnel. But the comet is still intact. The final penetrator carries a 300 million ton equivalent nuke, 20,000 times Hiroshima. It detonates deep inside the tunnel, vaporizing the comet from within. Humanity is saved. To make this happen in reality requires unprecedented planning and precision. Yet it is possible, not sci-fi. With today's rockets, engineering, and knowledge. Do you want to personally drill into an asteroid? If you do, think carefully. But remember, the penetrator idea offers a realistic path to defend Earth against many asteroid threats. We can implement it with current technology, provided we have early detection and rapid response. Early detection, 2 weeks for small killers, months for giants, is crucial. Without it, even the best tools won't help. We must invest in surveys, telescopes, and readiness, so we are not taken by surprise. Imagine the difference a single week could make, if we had the right systems in place. This is not a tale of doom, but of potential action. With foresight, we can turn apocalypse into prevention. The physics are brutal, but understandable. The engineering is immense, but achievable. The question is political will. Will we prepare? Will we fund the surveys and the rockets? If we do, our grandchildren may never fear the cosmic lottery as their ancestors once did. If we don't, a single bullet from the sky could end most lives on Earth. That is the stark choice we face. But hope remains. Technology and ideas exist. We need coordination, funding, and early detection. So the next time you hear about a near-miss asteroid, remember we have options and more could be done. From tiny penetrators that turn extinction into fireworks, to massive coordinated missions aimed at mountain-sized threats, human ingenuity gives us a chance. But only if we act before the clock runs out. The cosmos is full of dangers, but also solutions. Let's choose to be prepared. If you enjoyed this deep dive into planetary defense, please like and subscribe for more. Let me know in the comments, which method do you find most believable, the penetrator, the nuke, or something else? And if you want a follow-up, I can dive into the engineering details, the rockets we'd need, and the costs involved. Thanks for watching. Stay curious and keep looking up. Humanity's survival may depend on it. End credits coming up. Visuals, simulation of penetrator impact, debris cloud, Earth safe. Sources and further reading in the description. Support planetary defense initiatives if you can. This video condensed complex science into an accessible story. Accuracy prioritized. Simplifications made for clarity. If you're into space tech, consider donating to detection projects, or get involved as a citizen scientist. Final reminder, early detection saves lives. Invest in the eyes that watch the sky. Trailer, next video will cover historical impacts and the ecological aftermath in detail. Subscribe and hit the bell if you want that episode. Thanks again. See you next time.